Alright, so I think I'm recording. We've been looking at rational functions, which are a ratio of polynomial functions. The numerator and the denominator are each polynomial functions. We've been asked three things: to find the domain and to identify if there's any vertical asymptotes or holes in the graph of this function. So when we're finding the domain of a function, we normally have two considerations to consider. Avoiding taking an even root of a negative number and avoid division by zero. Well, we don't have any radicals here because in polynomials we will never have the radical of a variable. So all we have to worry about is the variable in the denominator. So we focus, factoring becomes an essential skill, and we've got our x method. If we can't factor, we've got completing the square of the quadratic formula. If it's a higher order polynomial, we have the rational zero theorem. So we do have various tools now to factor this denominator. 5 minus x is my numerator, and my denominator, if I factor out a 2, because that's the greatest common factor, I have x squared minus 25. That's a difference of perfect squares, so that factors. So I have 5 minus x over 2 times x plus 5 times x minus 5. So my domain is the set of all real numbers that excludes negative 5 and positive 5, because they are the two values that if you square them and subtract 25 that give you 0, and you want to avoid that. So we exclude negative 5 from the domain. We exclude positive 5 from the domain. In interval notation, it's always a smaller number comma a larger number. Now I can look to see if anything cancels. Does this fraction reduce? And it does. I will take the opposite of 5 minus x, which is x minus 5, and I can see then that that factor of x minus 5 cancels with this factor of x minus 5. That x minus 5 divided by x minus 5 is just 1. So I have negative 1 divided by 2 times the quantity x plus 5. So my negative 5 here, negative 5 plus 5, that's the vertical asymptote, because that's the factor that remains in the denominator. So when I have something that's excluded from the domain of a rational function in the graph, it'll either appear as a vertical asymptote or as a hole. So here we have a vertical asymptote, and that's the line x equals negative 5. There's a hole in the graph, and every hole in the graph we want to provide the location of that hole, an x coordinate and a y coordinate. The x coordinate's pretty easy. From this canceled factor, if you set that equal to 0, 5 minus 5 gives you 0. We can't plug this 5 into the original function because it would be 0 divided by 0, but if we plug this into the reduced function, then we'll get the y value of this hole. Now remember, this point is not on the graph, it's excluded from the graph, but it's so infinitesimally close to it that without making a hole there, there's not really a way to illustrate on the graph, like I say, without drawing a hole, that it's not part of the function, it's not part of the graph. So if I plug in 5, I get negative 1 divided by 2. Well, 5 plus 5 is 10, and 2 times 10 is 20. So here's my answers for problem 6. I can verify those answers in a graph. There's plenty of graphing calculators on the web. Some of you, if you're juniors that are going on to take calculus, you'll need at some point to invest in a graphing calculator, but for this class, for our purposes, if you want to hold off on that investment because it is a lot of money, we can just use something that's free that's on the web. Alright, so 5 minus x was my numerator, 2x squared minus 50 is my denominator. X equals negative 5 is going to be a vertical asymptote. Let's change the color. Let's change this to a dashed line to make that blue. And let's zoom out or zoom around to see what's going on with our graph. And there we have it. So sometimes they'll refer to it as a window. Since this is going off to infinity in all directions, we've got to maybe center this graph or use the zoom in or zoom out to kind of find the portion of the graph that we're interested in. We also had a hole in the graph, so let's make a table. And we know that negative 5 and positive 5 are not in the domain, so they'll appear as undefined in our table. We saw that negative 5 was the vertical asymptote. Now, at positive 5, we don't see a vertical asymptote, so we know by logic that that's a hole in the graph, but you can't really, I don't know, yeah. If I do hold my mouse over that, you can kind of see that it's undefined, but you have to be right on top of it there. And like I say, it doesn't show it. Probably in later versions, they'll figure out a way to illustrate that there's a hole there. Now we can figure out that there's a hole there by graphing the reduced function, the negative 1 divided by the quantity, what was it, 2 times x plus 5. So when we go to look at the appearance of these, they're going to look the same. So if I toggle this green off, well, you can't see that very well. Let's change these colors. Let's make this red. Well, it's still hard to see with the black. Maybe I should change that black to something else. I don't know what will really show up over the other. Well, there's the black might. Alright. So if, I guess I had, which one does it matter? Okay, the green doesn't show up that well. Sorry about this. There we go, maybe. Oh, the table there is. Okay, so this original function, I've got it in orange, and if I come in to the reduced function and make it black, you can see that it appears to be the same. The only difference between the two is that the one in black does not have holes at negative 5, or excuse me, at positive 5. We have negative 0.05, and that's the same as that's the decimal number of this fraction, negative 1 over 20. Negative 1 over 20 is going to be negative 0.05. Alright, so I hope that helps. Our graph does verify our answer. Talk to you later.